Hello guys and welcome back. Today we are going to be doing LeetCode question number 5, which is the longest palindromic substring. So it says given a string S, return the longest palindromic substring in S. And then if you hover over a palindromic substring, you are basically given the definition. It says a string is a palindromic if it treats the same forward and backward. So example 1 says input, if you're given S is equal to BABAD, the output is BAB, with the explanation that ABA is also a valid answer because it's also a palindrome. And then example 2 is CBBD and the output is BB. So you're also given some constraints that say like 1 is less than or equal to the length of the string, which is less than or equal to 1,000. And then also S consists of digits and English letters. So in this video, we're going to go over like the brute force approach, which basically checks for all the substrings that are possible within the string itself. And then just make sure that we return the largest after considering all the solutions. So it's going to be definitely slow, but it's like the most obvious solution for most people, that should come to mind when you're given a question like this. So first up, we're going to code up a method that will tell us if a string is either a palindrome or not. So we just say public boolean is palindrome, which takes in a string S. Then we check for the base case. If S is equal to now, we're going to return false, that is not a palindrome. So this also depends upon what you're given. In this case, this check is not going to be very useful because we've been told that the length of the string is at minimum 1. But depending on what the interviewer, if it's an interview, tells you about the now condition, you can either return true or false. In this case, we'll return false. And then we initialize some pointers to iterate over the string from both ends. So we'll say int left is equal to 0, and then right is equal to s dot length minus 1, and then while left is less than or equal to right, if s dot character at left is not equal to s dot character at right, we're going to return false. Otherwise, we'll say left plus plus and right minus minus. If we manage to go through this whole loop and all the characters are equal, then we can return true, that indeed the string is a palindrome. Then now, actually this method is supposed to be outside, sorry about that, put it here. Right, then we move on. We just format the code. Where is it? I think it's this one. Yes. Then now this method, to return the longest palindrome, first of all, we're going to need a string to store the result, which we're going to return. So we'll say string result is equal to now, and then we can start iterating and considering all the strings. So basically, what we're going to be doing is, for example, if you have a string BABAD, right, you start off by passing B, then you pass on BA, you pass on BAB, BABA, and each time you're passing these strings, you're checking if it's a palindrome. If it is, you check if its length is greater than the result. If it's the length is more than the result, then you replace the result with that. If it's not, you keep on looking. So the loops say for int I is equal to 0, I is less than s dot length and I plus plus, like this. And then our second loop, int j is equal to, so since we want to check for all the substrings, I think it's going to be better to check from the largest, instead of passing B and then BABAD, we can pass the whole string first, and then we keep on shortening it by 1, so that if we find a palindrome at any point in time, and this length is more than, right, as long as it's a palindrome, we can just immediately just stop checking, because if we find a palindrome that is, let's say if BABAD is a palindrome, there's no point in considering BABA anymore. So that's like a small optimization we can do. Might not increase the speed that much, but we'll see. So we'll say for int_j is equal to s dot length, and then j is greater than I, and then j minus minus. And then we want to store the result, like, the substring that we're going to be checking in something. So we'll say current string char is equal to s dot substring, starting from position I and ending at j. So now we have the actual string, right? And then we say if is palindrome, right? Palindrome. If is palindrome char, right? So now we know it's a palindrome, right? First of all. So now we say if, right, result is equal to now. So maybe result was not initialized, right? Or result dot length is less than the current substring dot length. Then we want to replace it. So we'll say result becomes equal to current, right? So at this point, right, one thing is we've found the palindrome. Like, we know that it's a palindrome, and we're taking like the biggest length you can ever find. So at that point in time, it makes sense to just break. There's no point to keep on checking. But if this was the case, we've already replaced the result, so that's good, right? And then at the end of everything, after doing all these iterations, we're just going to return the result. So let's check if this solution passes the cases that we've been given. Let's see. So as you can see, it passes both case 1 and case 2. Let's just submit and see how fast it runs. So and as you can see, it works. So like we said, it's not going to be the fastest solution, but it's the most obvious solution that you can think of at the top of your head. You check all the strings. In this case, we didn't check all of them, but you check all the biggest you can find after starting at any position. And then yeah, and then it beats off 0.16%. The complexity is going to be most likely of n cubed. Let's just see what this 2 tells us. Yes, so it's O of n cubed. So yeah, this is how you can solve this question. This is just one of the approaches. If anyone has any better approaches or more interesting solutions or questions, please type them in the comments. But until then, see you in the next video.